Welcome to our revision series. Okay, so today we are going to take a look at geometric and quadratic series. Okay, so we are going to have a question on these two series, and I'm going to work out explaining some concepts and some tips we can use in our exam. Before we go in, let me explain about this series and the formulas we need to use inside. Okay, first let's take a look at geometric. A geometric series is a series such that if we have a number, a first number, we are going to multiply it by a certain number, which we call R, to get another number, okay, which we call A2. Then we are going to multiply again with the same R to get A3. Okay, so this means that our R is going to become A over A2 over A1, and this R is going to equal all over until the last term. Okay, so this means that A3 over A2, okay, is going to be equal to R, and the an is going to be over a n minus 1 here. Okay, so this means that we're going to have a series which looks like this. It is a common ratio here. Okay, so these terms might be increasing or might be decreasing. Okay, but they have a common ratio between them. Okay, so there are some formulas you should know on this series. Okay, so the first formula is to have any term, to the formula of any term is given by the formula a r n minus 1. Okay, so this means that at a here you are going to substitute the first term. Okay, then r here you are going to substitute the common ratio. Then on this n you are going to substitute which term are we talking about. If you are talking about the first term, just substitute n is equals to 1, then you're going to get your term. Okay, now let's talk about the sum of these terms. Okay, so given the terms, let's say you are given the a value and the r value. Okay, you are going to, and you are given find the sum of about n. Okay, you want to find the sum. Okay, sum of n terms. Okay, so the formula for this one is sum of n terms is going to be given by a 1 minus r to the power n over 1 minus r. Okay, so this is going to be our formula. Okay, so if you have a, r, and n, you can easily find the sum of n terms. Okay, so when this r is between 1 and minus 1 and 1, okay, so if this r is become minus 1 and 1, okay, so from minus 1 to 1, we have what we call the sum to infinity. Okay, so this is the sum of numbers of all the numbers that can be there in the series because this is decreasing, right? Okay, so it keeps on decreasing. Okay, so sum to infinity is a sum where we want to cater for all the terms. Okay, so the sum to infinity is given by, okay, so the sum to infinity is just derived from this equation. Okay, if you put to the power infinity here, we're going to see that here we're going to get 0. So our formula is going to become a over 1 minus r. Okay, so this is the formula of the sum to infinity. Okay, so this is the formulas, the three formulas you should remember on this series. Okay, so we're going to be using these three formulas. So make sure I remember them. Okay, next let's go to the quadratic series. Okay, so for a quadratic series, there's just one formula we have to share. Okay, so if our series, the next term, we have a term 1, term 2, term 3. Okay, so if all of these terms, these three, okay, term 4, okay, if you take any three of these terms, okay, if they are following a certain order, like Tn is equals to an squared plus bn plus c. Okay, so if they are following this order, to find any term of this, you just have to substitute n here. Note that here a, b, and c, they are constant. We should find them for any quadratic series. Okay, so this is it. These are the formula we're going to be using today. This formula and these three formulas. Okay, so please make sure you subscribe. This is going to be our question for today. It is a question on geometric and quadratic series, as I said here. So the first question, 2-1, given the geometric sequence, this one, we are supposed to find the common ratio, and we are going to find how many terms are in the sequence. Okay, so we're going to use this term to find the value of how many terms are there in between. And then next one, we're going to give, we are given this one, it is a sum to infinity. Okay, so if it's a geometric, you see sum to infinity, this means that our r is between minus 1 and 1. Okay, so it's in between here, minus 1 and 1. Okay, so we're going to determine the value of m. Okay, so it is very easy. I'll show you how to do it. Then we have a word problem here. The third term of a geometric series is 18, and the fifth term is 162. We're going to determine the sum of first, 7 terms. Okay, with the formula we have, we're going to determine the sum of the first 7 terms, and we are told here that r is less than 0. Okay, so here. Then the other thing is the general term of a quadratic number pattern is the general form. We have a quadratic. I told you about this one. Okay, so we just given what you know. Then the first term is 8. Okay, so we're going to use this as the equation, and the general term of the first difference of the pattern is, okay, so the first difference. Okay, so this means that the second term and the first term, they have this difference. Okay, so we're going to use this difference to find our solution. So we are told here that we have to find determine the next 2 terms of the quadratic number. Okay, so we're going to determine the first 2 terms of this pattern. Then hence or otherwise, we are going to show that this pattern it shows this formula. Okay, then after that, we are going to prove that which term of the quadratic number will be equal to 3050. Okay, so this is it. This is our question. Okay, so you can pause here and try to solve it on your own and come to check for the answers. Okay, so this is it. We're going to solve each of these questions, giving you tips and giving you insights. Let's start with the first part. It says that given the geometric sequence 9 over 2, 9, 18, then 2340. Okay, so the first thing is you're going to determine the value of r, which is the common ratio. Okay, so this is very easy. To find the common ratio, you just have to divide 2 consecutive terms. So it's either you take 9 and divide it with the 9 over 2, or you take 18 and divide it with 9. Okay, so let's say do both. Okay, so here we can say 9 divided by 9 over 2. Okay, here we can see that our answer is going to become 2. Then if you divide again 18 and 9, we're just going to get these 2. Okay, so this will be our common ratio. It is that common ratio, just divide the next term with the previous term. Okay, as easy as that. Okay, then the other thing is how many terms are there in a sequence. Okay, so this is a bit tricky, but it's easy. Okay, so we're going to use the formula of any term in an arithmetic sequence, which is any term is given by a r to the power n. Okay, so every term we want is going to be given by this one. Here we know our r, we have this is our common ratio. Then our a is the first term, which is going to be 9 over 2 in this case. Okay, so now we just have to substitute it here. So what you're going to do is you're going to use this last term to find our answer. Okay, so we're going to say our last term is 2304. Then you're going to say our a is 9 over 2. Then our r is 2. Then to the power n minus 1. Okay, so our duty is to find who is n. Okay, so now we just have to divide here. If we divide here, if we multiply here, we're going to multiply this and this. Okay, so this means that 2304 is going to be multiplied by 2. Okay, so I think we're going to get 4608. 4608. Okay, so it's equals to 9 multiplied by 2 n minus 1. Okay, so as this is that, now we just have to simplify this to get our answer. We divide this by 9 and we divide this by 9. Okay, so we're going to get our answer is equals to 2 to the power n minus 1 is equals to 512. Okay, so this one we just have to say using the laws of indices, we can say 2 to the power n over 2 is equals to 512. Okay, so this is it. So now we just have to say 2 times 512. Okay, so we're going to get 2 to the power n is equals to 1024. Okay, so 1024 here. So now we just have to simplify this. Okay, so to simplify this, the easy way is to use, you can use lean. It's the easy way. You have your calculator, or you can just let's say lean 2 to the power n is equals to 1024 is equals to lean 1024. Now we just have to simplify this. It becomes n lean 2 is equals to lean 1024. Okay, now our n is going to become lean 1024 over lean 2. Okay, I believe you can find this on calculator, and it's going to give you an answer which is a whole number. Obviously, our n has to be a whole number. If you that's a red flag if you get your answer which is not a whole number. Okay, so we're going to get our answer n as 10. Okay, so this means that there are 10 terms in this series. Okay, so from here you can solve there are other many ways to solve this equation. I just used this one, which is a more direct one. You just have to apply lean and apply the laws of logarithm and get your answer. Okay, so this was this. Our answer for the first one is here. We can know that our common ratio is 2 and there are 10 terms. Okay, so these are our answers. As easy as that. Okay, so let's go on to the next question. This question says that given that the sum to infinity of this term from k is equals to 1 up to infinity is 12. Okay, so determine the value of m. Okay, so when you are given the series like this, let's try to break it down to become a statement we know. Okay, so we know that if we take our k value, the only thing we can hold on here is know that the sum of infinity is only when it's a geometry. Okay, so we can find only sum to infinity when it's a geometric sequence. Okay, so this means that it's a geometric sequence. Okay, so the first our role is to find the common ratio. Okay, so to find the common ratio, what do we do? We find this first term of this number. What do we do that? The first term is 6m, then k minus 1. Okay, so to find the first term, we just have to substitute k is equals to 1. Okay, so this means that we're going to get our first term as 6. Okay, then the second term, okay, this was the first term. Then the second term, okay, so the second term we just have to substitute k is equals to 2 on this, only on this. Okay, to find the second term, we just substitute 2 here. Okay, so we're going to get our second term as 6m. So to find the common ratio, we just have to say second term divided by first term. Okay, so this is 6m over 6. Okay, so now we can know that our common ratio is m. Okay, and m is what we are supposed to find here. Okay, so now it's now easy. Okay, so now we are going to go back to a formula of sum to infinity. I told you that sum to infinity of a geometric term is given by a over 1 minus r. Okay, so this is where we get sum to infinity. Okay, so but now we are told that sum to infinity is 12. Okay, so if we substitute 12 here and we substitute our a here, our a is the first term, which is 6. Then our r here, which is m. We can simply find the m. Okay, so let's go on. Here we can say that it's 12 is equals to, let's substitute our a is 6. Then you can say 1 minus r. Our r is m, so we substitute m here. Okay, so now we can divide this 6 and divide this one. We are going to get 2 here. Okay, now we just cross multiply. It becomes 2 minus 2m is equals to 1 minus 2. Okay, so we're going to get minus 2m is equals to minus 1. Okay, so this means that our m value is going to become half. Okay, so it's easy as that. So m is equals to half. Okay, so we have found m using this little. Okay, so note that from here, you can solve this equation any way you want. I just chose this way. Okay, so the key points here was to make sure you know this formula and you know that you substitute the first term and the second term to find your R. And that is that. Okay, so this is our M. Let's go to the next question. Okay, our next question is saying that the third term of a geometric series is 18. Okay, so this means that T3 is equals to 18. And the fifth term is 162. This means that T5 is 162. Determine the sum of the first 7 terms. Okay, so the first thing we have to know when dealing with this series, the first thing you know when geometric series, make sure you know A and R. Okay, so this is what we find. A is the first term and R is the common ratio. Okay, so after you know this, you just have to do a substitution. Okay, so let's try to find A and R. We know that any term of a geometric sequence, any term is found by saying A r to the power minus 1. Okay, so this is it. So now our duty is just to find a and r. And let's substitute this, what do you know here? So we know that T3 is equals to 18. Okay, so we're going to substitute T3 and 18. Okay, this is 3 and 18. So we're going to substitute uh, T3 is equals to 18 when a, r, and n is equals to 3 in this case. So we're going to get r squared here. So this will be our first equation. Elaborate one. Then we're going to substitute this again on this. Okay, so we're going to substitute 162 here, and we're going to substitute 5 on n. So we're going to get r to the power 4. Okay, so it's now easy. We can solve these two simultaneous equations. Okay, how do we solve them? Let's just divide them. Okay, so this means that we are going to say 18 over 162 is equals to a r squared over a r to the power 4. Okay, so this means that we are solving just simultaneous equation. They're easy, right? So what we're going to do is we're just going to cancel out here. Then we're going to say 18 over 162. 18 into 18, 1. Then 18 into 162. We're going to get Okay, so 18 into 162, we're going to get 9 here. Okay, so this is it. We have 9 here. Okay, so we just have to cancel r squared here. Then we're going to cancel r squared here. So we're going to remain with r squared. Okay, so our equation is going to become 1 over 9 is equals to 1 over r squared. Okay, so make sure you got it right here to come here. Okay, so you can solve in any way. These are just equations. Our concept was here. Okay, so now we just have to simplify this. We're going to get that r squared is equals to 9. So this means that r is equals to plus or minus 3. Okay, so if we keep a square root here, both sides, we're going to get r is equals to plus or minus 3. Okay, so in advanced maths, make sure that whenever you keep a root here, root 9 is going to give us a positive and negative answer. Okay, so in this case, we are told that where r is less than 0. Okay, that means that r is equals to minus 3. Okay, r is less than 0, we are told. Okay, so now let's go on to the next one. We have found r. It's our duty now to find a. Let's substitute our r here. Okay, so this means that 18 is equals to a. Our r is minus 3 squared. Okay, so this means that it's going to become 18 is equals to 9a. Okay, so this means that if you divide both sides, we're going to get our a as 2. Okay, so our a is 2 and our r is minus 3. Okay, so now we know our equation of sum of n terms in geometric series. I told you that it's a 1 minus r to the power n over 1 minus r. Okay, so now we have our a, we have our n, we have our r. Our duty is just to simplify. Our a is 2, so substitute 2 here. Then 1 minus, our r is minus 3. Then our n, we were told that it's 7 terms. 7 terms. Keep note. So we just have to say the power 7 here. Then you substitute 1 minus 3. Okay, so your duty is now just to simplify this. In this case, you're going to get the sum of the 7 term as 1094. Okay, so this is going to be our answer as easy as that. The first thing we did was to make sure we find a and r. Okay, how do we find it? We use this equation. We know any term of a geometric sequence is given by this term. Then we solved our simultaneous equation. Okay, so from here you can solve any way you want. It's just simultaneous equation. Okay, so just solve. We found that our r is equal to 3. We note that here r was said to be minus, it was said to be less than 0. Okay, so this means that our r, the plus 3 is not valid here. Our r is minus 3. After that, we just have to substitute here to find our a value. After finding our a value, as easy as this, we just use the formula of sum of n terms. Okay, here this is our formula. Okay, we'll get this. Okay, so this means that you have to master this formula and this formula for this one, as easy as that. Let's go on to the next question. The general term of a quadratic number pattern is given by, okay, we already know this equation. It is the general term of a quadratic number. It's a quadratic equation. Okay, so its first term is 8. Okay, so now we know that T1 is equals to 8. Okay, then the general term of the first difference. Okay, the general term of the first difference. Okay, so this means that if you say 2 then minus T1, we're going to get, which is represented by TK, which is equals to 4K minus 2. Okay, so that's it. Okay, so that is what we have. Okay, so determine the next two terms of the quadratic number pattern. Okay, so as easy as that, we just have to know that T2 minus T1 is going to give us this one. Okay, so our duty is just to substitute this one. Okay, so now let's go on. So we're going to say T2 minus T1. Okay, we want to find T2 minus T1 is equals to 4K minus 2. Okay, so substituting these two, we're just going to use K. Okay, this is the first difference. Okay, so this is the first difference from 1 to 2. It's the first difference from 1 to 3. From 2 to 3 is the second difference. Okay, so we're going to substitute K is equals to 1 here. Okay, so this is because this is the first differences. Okay, so the first differences, they mean the first differences from T1, T2, T3, yes, and so on. Okay, so this means that we are going to substitute K is equals to 1 here. So T2 minus T1, we know what it is 8. Then here we are going to know that 4K, K is 1. Okay, so it becomes 4 minus 2. If we solve this, we are going to get that T2 is equals to 10. Okay, so this will be our second term. We already found. We want to find the next term. Okay, so we're going to use this philosophy again. So we're going to say T3 minus T2 is going to be 4K minus 2. Okay, after that, all you have to do is you just have to to substitute the value of k and the value of t2. We know that t2 is 10, so this means that t3 minus t2 is 10 is equals to 4. Then k is 2 in this case, minus 2. Okay, so we're going to get t3 minus 10 is equals to, in this case, it becomes 6, right? So this means that t3 is going to become 16. Okay, so we have successfully found the first two terms. Okay, so we can know that the t2 is equals to 10 and t3 is equals to 16. Okay, as easy as that. Okay, so that was that. Let's go on to the next part of this question. Now, the other part is saying, hence or otherwise, show that general term of the quadratic pattern is given by. Okay, I usually choose hence because it will be the smallest part. Otherwise, it can go get you there, but this one is the smallest part. Okay, so now let's take the information we have from the previous. We got that T1 is equals to 8, then T2 is equals to 10, then T3 is equals to 16. Okay, so this is the important information we got from the last question. Now our duty is just to prove Tn is given by 2n squared minus 4n plus 10. Okay, so from our general formula, we know that Tn is given by a n squared plus b n plus c. Okay, so let's substitute t1, t2, and t3, and we can get our answer. Okay, so let's substitute t1 first. So it's going to become 8 is equals to, then our a is the value we want to find, and we know that n is 1 in this case. In the first one, n is equals to 1. Okay, n is equals to 1. If we substitute n is equals to 1, we substitute this. Okay, so this means that n squared is going to become 1 plus b, then plus c. Okay, so if we substitute 1, we're going to get this one. If n is equals to 2, we are going to get a 10 is equals to, if we put 2 here, it's going to become 4a plus 2b plus c. Then after that, we're going to say n, when n is equals to 3, we're going to substitute 16 is equals to, if we substitute here, we're going to get 9a plus 3b plus c. Okay, so now our duty is just to take these three equations and solve them. Okay, so as easy as that. Okay, so now let's solve this equation. First, let's make C subject to formula and substitute it. Okay, so if you make C subject to formula from equation 1, it's going to become C is equals to 8 minus A minus B. Okay, so this is what we're going to substitute from the two equations. So we're going to get, let's put the variables in the first side. So it becomes 4A plus 2B. Substituting C, we're going to get plus 8 minus A, 8 minus A minus B is equals to 10. Okay, so if we simplify this here, we're going to see that 4A minus A is going to give us 3A, then 2B minus B is going to give us B. Then if you send this 8 this side, okay, we're going to get here, we're going to get 2. Okay, so this is our equation. Let's say this is our equation 4. Then let's substitute again this C in this equation, equation 3. So we're going to get that it's 9A plus 3B plus, okay, C, we're going to substitute this 8 minus A minus B is equals to 16. Okay, so here we can see that 9A minus A, we're going to get 8A. Then 3B minus B, we're going to get 2B. Then 8 here, if we send it to this side, we're going to get it's 8. Okay, so this is going to be our equation 5. Okay, so now our duty is to solve equation 4 and 5. Let's put B subject to formula here from 4. Okay, so from 4 we can know that B is equals to 2 minus 3A. Okay, so substituting B in this equation, we're going to say get that 8A plus 2B is going to become 2 minus 3A is equals to 8. Okay, so now solving this, we are going to get here we're going to get 8A plus here 4 minus 6A is equals to 8. Okay, so here 8A minus 6A, we're going to get 2A. And if you send this 4 this side, it's going to become 8 minus 4, which is going to become 4. Okay, so this means that in this case, we're going to get A is equals to 2. Okay, after finding that A is equals to 2, let's substitute here. We're going to say B is equals to 2 minus 3. A is equals to 2, right? So we're going to get B is equals to minus 4. Then after that, let's substitute A and B to this equation to find C. This means that we're going to get C is equals to 8. A is 2 minus B is minus 4. Okay, so solving this, we're going to get our answer 8 minus 2 it becomes 6. Then here plus 4 it becomes 10. Okay, so after that, we've shown that A is equals to 2, B is equals to minus 4, and C is equals to 10. Okay, so now we can substitute to our equation here. Okay, substituting to our equation here, we're going to get Tn is equals to A is equals to 2, n squared plus, and B is equals to, here it's minus, right? So minus 4, n plus C is equals to 10. Okay, so this will be our solution as easy as that. That was that. Okay, so let's go on and see the last part of the question. Okay, let's go on to our last question. Our last question is saying that which term of the quadratic number pattern will be equal to 3050? Okay, so let's go and write our equation of the quadratic pattern. Our equation is saying that Tn is equals to 2n squared minus 4n plus 10. Okay, so this is our equation. Okay, so our duty here, we just have to say substitute Tn and find the value of n. Okay, so how to do that? We're going to say 2n squared minus 4n plus 10 is equals to 3050. Okay, so after that, we just have to solve this quadratic equation. How do we solve it? We just have to put this thing this side. Then it becomes 2n squared minus 4n plus 10 minus 3050 is equals to 0. Okay, so simplifying this, you're going to get 2n squared minus 4n. Then this one, we're just going to say this one minus this one is going to start with minus 3040 is equals to 0. Okay, so you can choose to simplify like I'm going to do here. We divide each term by 2. If we divide each term by 2, we're going to get n squared minus 4n minus 2n, n squared minus 2n minus, here it's going to become 1 0. It's going to become 1520. Okay, is equals to 0. Okay, so now our duty is just to simplify this quadratic equation. Simplifying this quadratic equation, we just use the quadratic formula for a clear view. Okay, so this one it becomes minus b plus or minus root b squared minus 4ac. Okay, here we can see that our b is minus 2 in this case, so it's going to become minus 2, then plus or minus root b squared, b is 2, so if we square it, it's going to become 4, minus 4, our a is 1, then our c is minus 520. Okay, so we're going to divide this, okay, this equation is going to a, so we're going to divide it by 2 here. Then solving this, our answer, we're going to get, if you just punch all of this on calculator, first choose plus here and choose negative. See which one is going to get negative. Know that our n is not going to give us negative, right? It's a positive number in this case. So we're going to get our answer as 40. Okay, so the other answer is going to be negative, so we won't care about that one. Okay, so this means that the fourth term, the 40th term is going to come 3050. Okay, so that was that on our revision. Make sure you comment how was it, and you comment your answers if you have tried on your own. Then make sure you subscribe so that you won't miss the next revision we are going to do on another important topic. Okay, so please stay in touch.